If I take just the INSERM teams in this multi-body subject-specific institute, or ITMO, for circulation, metabolism and nutrition, 25% of the researchers with tenure are from the CNRS. So the need for coordination is obvious. There's also a need for coordination at another level. These ITMOs function at a national level, but dialogue is needed at local level, with the universities, to try and strengthen research, to put French research at the top level in 5 years. During our fortnightly meetings, we've developed a strategic plan, and we're in the process of devising a contractual objective, which we're endeavouring to hammer out for each organisation, INRA, the CNRS, and INSERM. That's the background for scientific planning, and in this respect, interaction with the National Research Agency, the ANR, is obviously decisive and will continue to be in the years to come. The logistics are based on all the services that already exist in the organizations, whether it's for evaluation or communication. This is very important because, as I see it, the aim is not to duplicate these services in each ITMO. There's very close coordination between the various ITMOs. We meet once a week, and all the major decisions that are made jointly by the different ITMO directors and the directors of the main organizations. I think this is essential. The aim is not to put barbed wire around the ITMOs. Multidisciplinarity has perhaps become rather a hackneyed expression, but it's important, and the need to extend the scope of what might appear to be simply biology seems to me to be very important. The challenge will be to explain the sometimes considerable differences in the incidence of certain diseases, geographical variations between countries or even regions in a particular country. And here, what we're going to have to find out is how a variable genome interacts with the environment. A second priority, I think, is inflammation. It's interesting to see that, for example, in the fruit fly, the hematopoietic system is in one single organ, and all the storage organs like adipose tissue, which in mammals is the liver, for example. We find very common cellular circuits between the hematopoietic systems and the organ systems. So it's no surprise, really, that inflammation and the molecules that define inflammation are currently therapeutic targets in a whole series of diseases that concern fields covered by the ITMO, which are often very common diseases that have a substantial impact on public health. I think a third priority is therapeutic innovation. In many of these common diseases, the treatments are palliative. A subject is not secreting insulin anymore, so he's given insulin injections. But it would be better to prevent the condition occurring in the first place, and that is the challenge. So this is basically what we're up against. There's one last important field that I haven't mentioned, and that's cell development. We're beginning to be able to grow organs that are not absolutely complete, but which I think will be in the coming years. This is a major challenge in medicine because organ replacement is, of course, a whole medical field in itself.